Somewhere in the vast expanse of the universe, hidden among countless swirling galaxies, lies a cosmic giant so immense it defies comprehension. The NGC 4889 galaxy isn't just another speck in the night sky. It's a colossal titan, one of the largest galaxies ever discovered, stretching across unimaginable distances with gravity so powerful it warps the fabric of space itself. But size isn't the only thing that makes this galaxy extraordinary. Within its mysterious depths, tucked between the glow of ancient stars and the whispers of black holes, lurk objects so strange, so utterly baffling, they challenge everything we think we know about the cosmos. Imagine structures that bend the rules of physics, celestial bodies that vanish without a trace, and phenomena that leave even the brightest scientists scratching their heads. This is a place where the ordinary becomes irrelevant. Picture a galaxy so massive it could swallow our entire Milky Way without a second thought, yet its true enigma lies not in its scale but in the secrets it guards. Over years of observation, astronomers have catalogued 25 objects within NGC 4889 that refuse to fit into neat scientific boxes. Some emit signals that shouldn't exist, others appear and disappear like cosmic ghosts. A few even seem to defy the very laws that govern the universe. What are these anomalies, where did they come from, and what do they tell us about the hidden forces shaping the darkest corners of space? Today, we're setting out on a journey to uncover these mysteries. Together, we'll explore the most perplexing objects nestled within this galactic giant, diving into the stories behind their discovery, the theories that attempt to explain them, and the lingering questions that keep researchers awake at night. This isn't just a tour of distant celestial oddities, it's an invitation to witness the edges of human understanding, where the known universe meets the unfathomable. So buckle up, by the time we're done, you'll never look at the night sky the same way again. Deep within the swirling heart of NGC 4889, something invisible exerts an iron grip on the fabric of space. This is no ordinary black hole, it's a phantom, a cosmic enigma detectable only by the way its gravity bends light from distant stars, like a hidden lens warping the universe around it. Most black holes announce their presence with blazing accretion disks, superheated gas swirling at nearly the speed of light, but this one lurks in perfect darkness. No X-rays, no telltale radiation, just the silent, unmistakable tug of something massive hiding in plain sight. Scientists call it a naked singularity, a black hole stripped of the glowing debris that typically betrays its location. The leading theory suggests it might have formed in an unusually sparse region of the galaxy, where little matter was available to create an accretion disk. Another possibility, it could be the remnant of a direct collapse black hole, born not from a dying star but from the instantaneous collapse of a vast gas cloud in the early universe, skipping the usual stellar fireworks altogether. Either way, its existence throws a wrench into our understanding of how black holes evolve and interact with their surroundings. The real shock, though, is how this phantom defies detection by conventional means. Gravitational lensing, the bending of light around massive objects, is the only clue to its presence. Imagine staring at a starfield through a funhouse mirror, where pinpricks of light stretch and curve around an unseen void. That's how astronomers first spotted this cosmic ghost, yet every attempt to observe it directly has come up empty, leaving researchers to wonder, are there others like it lurking undetected across the cosmos? And if so, what does that mean for our maps of the universe's most mysterious structures? This phantom black hole isn't just a curiosity, it's a challenge. It forces us to rethink the tools we use to study the invisible giants shaping galaxies. If some black holes can hide so effectively, what else might we be missing? The answer could rewrite textbooks, revealing a universe far stranger and far more elusive than we ever imagined. Drifting through the outer reaches of NGC 4889, a celestial apparition defies all expectations. A nebula so bizarre it resembles a glowing, tentacled jellyfish floating in the cosmic deep. Unlike the familiar, wispy clouds of gas we often see in space, this structure pulses with an eerie rhythm, its tendrils stretching light years across the void while emitting radio waves in a pattern no natural phenomenon should produce. At first glance, it could pass for the aftermath of a supernova, the dying breath of a massive star. But the signals it broadcasts tell a different story, a looping, almost melodic sequence that repeats every 47 hours like a heartbeat echoing across the galaxy. The discovery sent shockwaves through the astronomical community. Normally, nebulae emit chaotic bursts of radiation, the leftover energy of stellar explosions. This one behaves more like a transmitter. Some researchers speculate it could be the shattered remains of a hypernova, a star so colossal its death throes twisted the surrounding space into this peculiar shape. Others point to the unnerving regularity of its radio pulses, suggesting the faint possibility of artificial origin. Could it be some form of alien megastructure, a beacon or relic from a civilization lost to time? The idea isn't as far-fetched as it sounds. On Earth, we've designed similar radio arrays to communicate across vast distances. The real question is, why would such a structure exist here in the depths of this ancient galaxy? Then there's the nebula's composition. Spectrographic analysis reveals heavy elements like gold and platinum floating within its gaseous arms, metals typically forged in the violent cores of collapsing stars. Yet their distribution is oddly uniform, as if scattered deliberately rather than hurled outward by an explosion. One hypothesis suggests the jellyfish might be the wreckage of an ancient cosmic collision, where two neutron stars merged in a cataclysm so immense it sculpted the surrounding gas into this haunting shape. Another theory proposes that the nebula is feeding. Its tendrils stretch toward a nearby cluster of young stars, as if drawing material from them to sustain its eerie glow. What truly baffles scientists, though, is how the structure maintains its form. Nebulae usually dissipate over millennia, their gases diffusing into the void. This one appears unnaturally stable, its delicate filaments resisting the pull of gravity and the chaos of interstellar winds. It's as though some unseen force, whether magnetic fields we don't yet understand or something far more exotic, holds the jellyfish together. Every answer leads to deeper questions, and with each observation, the mystery only grows. For now, the cosmic jellyfish remains an enigma, a reminder that the universe delights in confounding us. Whether it's the tomb of a dead star, the echo of a long-gone civilization, or something beyond our current imagination, one thing is certain. In the depths of NGC 4889, the ordinary rules don't apply. Tucked between the spiraling arms of NGC 4889, a celestial shard glitters with impossible brilliance, a rogue fragment the size of a small moon, its surface a labyrinth of razor-sharp carbon crystal. This isn't just another asteroid or wandering dwarf planet. Spectroscopic scans reveal a staggering truth: 98% pure crystallized carbon, structured like a diamond forged on a cosmic anvil. Astronomers believe it's a surviving piece of something far grander, a shattered diamond planet, once perhaps as large as Earth, now reduced to fractured remnants adrift in the void. How does such an exotic object come to exist? Picture a star system where a dying sun stripped away the outer layers of a carbon-rich giant planet, leaving behind a core under unimaginable pressure. Over eons, that pressure could have transformed the carbon into a vast, planet-sized diamond. Then catastrophe, a collision with another massive body, or a close encounter with a black hole's tidal forces, splintering the world into fragments. The miracle is that this piece endured, surviving billions of years in the galactic chaos without being pulverized or swallowed by a star. What's even more astonishing is how it gleams. Most free-floating planetary debris eventually becomes darkened by cosmic dust or irradiated into dullness. Yet this fragment reflects light with uncanny intensity, as if its crystalline structure somehow repels contamination. Some researchers suggest its surface might be constantly healing, microscopic carbon bonds reforming after impacts like a cosmic self-repairing jewel. Others propose it's shielded by an invisible magnetic field, a remnant of its planet's original core, deflecting interstellar debris. Then there's the question of its orbit. The fragment doesn't circle a star like normal planets. Instead, it follows a drunken, looping path through the galaxy's halo, untethered to any solar system. That's what makes its survival so baffling. Without the protection of a parent star's gravity, most rogue objects are torn apart or drawn into dense galactic regions. Yet this diamond shard persists, dodging stellar encounters like a seasoned cosmic nomad. Simulations suggest it may have once been part of a larger cluster of fragments, a scattered family of diamond worlds, with this piece being the lone survivor. Could there be practical value to such an object? Hypothetically, yes. On Earth, industrial diamonds are prized for their hardness and thermal conductivity. A fragment this size could revolutionize manufacturing or energy storage if we could reach it. But the real treasure lies in what it teaches us. Its very existence hints at planetary formation processes far more extreme than we've observed elsewhere. It challenges assumptions about what can endure in the interstellar wild, proving that even the most fragile-seeming structures can outlast empires of stars. For now, the diamond fragment remains both a scientific marvel and a poetic mystery, a glittering tombstone for a lost world, and a beacon reminding us that the universe's wonders are often stranger than our boldest imaginings. Among the countless wonders of NGC 4889, one structure stands out as utterly perplexing, a perfect spiral, etched against the darkness like a miniature galaxy trapped inside a galaxy. It shouldn't exist. Spirals this small, this precise, aren't supposed to form in isolation. Yet here it is, its arms curling with gravitational elegance, each curve defying conventional astronomy. At first glance, you might mistake it for a fledgling galaxy trying to birth itself, but scale tells a different story. This cosmic whirlpool spans just 200 light-years across, a speck compared to the grand spirals we know. So what created it? The answer might lie in chaos. One leading theory points to a dance of destruction. Picture two galaxies not colliding head-on but grazing each other in a gravitational tango. As they pass, tidal forces could have ripped a fragment of stars and gas free, sending it spinning into the void. Over eons, that fragment might have settled into this eerie, self-contained spiral. We've seen similar structures before, like the Medusa merger in another galaxy, but never one so isolated, so unnervingly symmetrical. The problem: there's no trace of the galaxies that supposedly birthed it. No debris field, no lingering gravitational signature, just the spiral floating like a cosmic orphan. Then there's the magnetic hypothesis. Some researchers argue the structure might be shaped by invisible forces, intertwined magnetic fields so powerful they've sculpted interstellar gas into this mesmerizing form. We know magnetic fields influence how galaxies evolve, but could they alone create something this intricate? The spiral's core emits bizarre radio waves, pulsing in a way that suggests immense magnetic activity. Yet even that doesn't fully explain its crisp geometry. Nature rarely produces such precision without a guiding hand. Perhaps most intriguing is the idea that we're witnessing something entirely new. Not a collision remnant, not a magnetic anomaly, but a phenomenon without a name. The spiral stars rotate at speeds that shouldn't hold it together, as if some unseen energy binds them. Its gas clouds glow with elemental signatures unlike anything else in the galaxy, heavy metals concentrated in patterns that resemble deliberate arrangement, not random scattering. Could this be the fingerprint of an unknown physical process, some hidden law of cosmic structure waiting to be uncovered? For now, the spiral remains an enigma wrapped in motion. It challenges our definitions, blurring the line between known and unknowable. Whether it's the ghost of a galactic near miss, a laboratory for exotic physics, or something beyond our current science, one truth is undeniable. In the depths of NGC 4889, even the simplest shapes can harbor the deepest mysteries. In the swirling depths of NGC 4889, a gas cloud the size of a small star cluster commits the ultimate cosmic rebellion. It moves in the wrong direction. While the galaxy's other structures obediently follow the flow of its rotation, this colossal formation drifts stubbornly against the tide, as if some unseen hand is dragging it backward through space. Gravitational models crumble in its presence. Normally, such a massive cloud should be torn apart by tidal forces or absorbed into the galactic dance. Yet here it persists, a renegade fragment spinning its own path through the void. What could possibly explain this defiance? One compelling theory points to dark matter, not just the invisible halo surrounding galaxies, but a concentrated knot of it lurking nearby like a cosmic puppeteer. If a dense pocket of dark matter tugs on the cloud with enough force, it could overpower the galaxy's rotational pull, wrenching the gas into its bizarre trajectory. The math almost works, almost. Observations show the cloud's motion is too precise, too steady for random dark matter interactions alone. There's something else at play. Then there's the external force hypothesis. Could another galaxy's gravity be influencing the cloud from afar? The nearest neighboring galaxy sits millions of light-years away, far too distant to exert meaningful pull. Unless, of course, NGC 4889 once cannibalized a smaller galaxy, and this cloud is the last remnant of that ancient collision, still carrying momentum from the encounter like a bullet lodged in celestial flesh. Spectral analysis supports this idea. The cloud's chemical composition differs slightly from the surrounding gas, hinting at an extraterrestrial origin. But the real curveball comes from the cloud's internal structure. Unlike typical gas clouds which churn with turbulence, this one rotates as a cohesive unit, its outer edges moving in eerie lockstep with its core. It behaves less like a cloud and more like a solid object, as though some force binds its particles together against the usual chaos of space. Some researchers speculate it might be threaded with exotic magnetic fields, or even crisscrossed by filaments of cosmic strings, theoretical defects in space-time left over from the universe's birth. The implications are staggering. If dark matter or hidden forces can sculpt gas clouds into such unnatural motions, what else might they be influencing without our knowledge? This rebellious wisp of gas could be the key to uncovering gravity's best-kept secrets, or proof that the universe still has rules we've yet to discover. For now, it drifts on, indifferent to our theories, a reminder that even the most fundamental laws of physics are negotiable in the right corner of the cosmos. Buried within the tangled starlight of NGC 4889, a cosmic metronome ticks with unsettling precision, an object blasting bursts of radio energy across the galaxy every 76 minutes exactly, like clockwork. Fast radio bursts aren't uncommon in the universe, but this one defies all expectations. Most FRBs erupt randomly, ephemeral flashes lasting mere milliseconds. This source, it's relentless, each pulse identical in strength and duration, as though engineered by some unfathomable intelligence. At first, astronomers assumed it must be a magnetar, a highly magnetic neutron star known to emit erratic bursts. But magnetars don't behave like this. Their emissions are chaotic, tied to violent starquakes rippling across their surfaces. This signal is too clean, too disciplined. The timing is precise down to microseconds, a level of regularity never observed in natural cosmic phenomena. It's as if the universe itself has tapped out a Morse code message, repeating the same sequence over and over into the void. The strangeness doesn't stop there. The bursts contain an odd spectral signature, a faint harmonic echo that shouldn't exist. When analyzed, the radio waves show subtle interference patterns, almost as if they've passed through some kind of filter or amplifier before reaching us. Natural processes rarely imprint such artifacts onto their emissions. Could this be evidence of technology? The idea isn't dismissed as easily as you might think. Scientists working with SETI, the search for extraterrestrial intelligence, have long speculated that an advanced civilization might use directed radio bursts as cosmic lighthouses, a way to announce their presence across interstellar distances. Then there's the location. The source sits in a curious pocket of the galaxy, not near any known star clusters or nebulae, but eerily isolated, as if deliberately placed in the quietest corner of NGC 4889 to avoid interference. Some researchers argue this positioning could be strategic, maximizing the signal's reach. Others counter that it might simply be a rare type of neutron star we've never encountered before, one locked in such a stable rotation that its magnetic field generates these clockwork bursts. But the most tantalizing clue lies in the signal's structure. Buried within the radio waves is a faint, repeating mathematical pattern, a sequence of prime numbers modulating the burst's intensity. Nature doesn't favor primes. They're the product of abstract reasoning, the building blocks of encryption and communication. Finding them encoded in a cosmic signal is like stumbling upon a stone tablet covered in perfectly carved letters amid an ancient wilderness. It begs the question, are we listening to the heartbeat of a dying star or the broadcast of something far more extraordinary? For now, the repeating bursts remain an open puzzle, one that straddles the line between astrophysics and existential wonder. Every new observation deepens the mystery, pulling us further into the enigma of NGC 4889, a galaxy determined to defy our understanding at every turn. Whether the work of nature or intelligence, one truth is undeniable: the universe is speaking. We just don't know how to listen. In the shadowy outskirts of NGC 4889, an invisible maelstrom churns a gravitational whirlpool where the very fabric of space seems to spiral inward, as though drawn down some cosmic drain. This is no ordinary void. While telescopes reveal nothing but empty blackness, the motion of nearby stars betrays the truth. Something vast and unseen twists here, its pull-warping stellar orbits into unnatural curves. Scientists call it the Dark Matter Vortex, a region where the universe's most elusive substance appears to behave in ways that defy every model we've built to explain it. Dark matter isn't supposed to clump like this. According to leading theories, it should form diffuse halos around galaxies, distributed smoothly like an invisible fog. But here, it's concentrated, dynamic, almost alive. The vortex's gravitational footprint suggests dark matter swirling in dense, structured currents, as if caught in an invisible whirlwind. Some observations hint at even stranger behavior. The rotation speed increases toward the vortex's core, breaking the established rules of galactic dynamics. Normally, gravity weakens with distance. This pattern implies dark matter interacting with itself in ways we've never witnessed, possibly through some unknown force beyond gravity alone. The implications are tectonic. If dark matter can self-organize into vortices, our understanding of how galaxies form and evolve may need radical revision. Current simulations struggle to recreate this phenomenon. They predict dark matter should be too cold, too sluggish to sustain such intricate motion. One provocative explanation suggests the vortex might be a fossil relic, a scar left behind when two streams of dark matter collided in the early universe, tangling into this permanent knot. Others speculate it could be evidence of warm, dark matter, a hypothetical variant with just enough energy to flow in these mysterious patterns. Then there's the eerie possibility that we're seeing dark matter responding to something even more enigmatic. The vortex aligns with no visible structure, no galaxy cluster, no black hole, no detectable mass. yet its gravitational influence stretches across hundreds of light years, as though anchored to some hidden titan beyond our perception. Could it be tracing the outlines of a higher dimensional object or resonating with a parallel universe's gravity bleeding into ours? These ideas border on science fiction, yet they're being seriously debated in peer-reviewed journals, a testament to how profoundly this anomaly disrupts the status quo. What's certain is that the vortex forces us to confront the limits of our cosmic maps. For decades, dark matter has been the universe's silent scaffolding, an invisible framework we assume but never truly see. Now, in the depths of NGC 4889, it's begun to dance, and we're only starting to grasp the steps. At the edge of NGC 4889's luminous sprawl lies a contradiction, a patch of space that glows softly despite appearing utterly empty. Telescopes reveal no stars, no nebulae, not even the faintest wisp of dust to scatter light. Yet this cosmic blank canvas radiates a steady, ethereal luminance, as if the void itself has decided to shine. The phenomenon, catalogued as the glowing void, defies conventional astrophysics. Light requires a source, yet here we find illumination without any apparent origin, a cosmic magic trick begging for an explanation. The glow isn't like the familiar scattered light of distant galaxies. Spectrographs detect a uniform emission across multiple wavelengths, from ultraviolet to infrared, with no spectral lines to identify its composition. It's as though empty space has been gently heated, though by what remains a mystery. One leading theory points to dark matter annihilation, the idea that unseen particles collide and decay within the void, releasing energy as they vanish. Certain dark matter models predict such interactions could produce diffuse light, though never before observed at this scale or intensity. Another possibility involves quantum vacuum fluctuations. According to quantum field theory, empty space isn't truly empty. It seethes with virtual particles popping in and out of existence under extreme gravitational conditions, like those near NGC 4889's central black hole. These fleeting particles might borrow enough energy to become real, briefly illuminating the void before disappearing again. The math suggests this could create a detectable glow, but matching the observed brightness would require conditions far beyond anything in our current models. Then there's the eerie alignment. The glowing void sits directly along one of the galaxy's faint magnetic field lines, as if positioned by design. Some researchers speculate this isn't coincidence, that the magnetic field might be funneling charged particles into the region where they interact with an unseen structure. Others propose the void could be the shadow of something far larger, a higher dimensional object whose presence warps space-time subtly enough to make nothingness appear luminous from our limited perspective. What makes the glowing void especially unsettling is its stability. Most cosmic light sources flicker or fade over time. This glow remains constant, unwavering across decades of observation, as though powered by some inexhaustible engine. If it's a natural process, it defies our understanding of energy conservation. If artificial, well, that opens doors best left unmentioned in polite scientific circles. For now, the void keeps its secrets, a radiant enigma proving that even nothingness in the right corner of the universe can become extraordinary. Hanging suspended in the gravitational tides of NGC 4889, a solitary star pulses with light that shouldn't exist, not here, not now. Its glow arrives stretched and sluggish, as if struggling to escape some invisible maw. Astronomers call this phenomenon extreme time dilation, where the fabric of space-time bends so severely that seconds for the star become years for us. Normally, we see such distortions only near black holes where gravity warps reality itself, but this star orbits nothing, at least nothing we can detect. Its stretched light suggests proximity to an object with the mass of 20,000 suns, yet telescopes reveal empty space where that colossal anchor should be. The implications rattle the foundations of modern physics. Einstein's theory of relativity predicts time dilation near massive objects, but those objects are supposed to leave traces: accretion disks, gravitational lensing, something. Here, the star's light behaves as if it's skirting the event horizon of a supermassive black hole, yet the region shows no such structure. One radical explanation proposes a naked singularity, a black hole so ancient it's consumed all nearby matter, leaving no glowing debris to betray its presence. Another possibility, a cluster of dark matter so densely packed it mimics a black hole's gravity without the usual cosmic fanfare. Either scenario would upend our understanding of how mass shapes the universe. Then there's the star itself, a bloated red giant that shouldn't survive this close to such titanic forces. Its outer layers should be peeling away, ripped into spiraling streams by tidal disruption. Instead, it burns steadily, its light stretched but unwavering, like a candle flickering behind thick glass. Spectrographic readings reveal another oddity. Elemental signatures in its atmosphere appear younger than they should, as if nuclear reactions on its surface are slowed by the same time warping effect distorting its light. It's as though we're observing a stellar paradox, a star existing simultaneously in fast-forward and slow motion. The most unsettling part, the star's orbit suggests it's not alone. Its path wobbles slightly, hinting at unseen companions, perhaps other stars similarly trapped in this gravitational hall of mirrors. If so, we might be looking at an entire system ensnared by whatever lurks in that darkness, a hidden architect bending spacetime to its will. Every new observation deepens the mystery, proving that even Einstein's towering legacy might only be a starting point for understanding the true strangeness of NGC 4889. Floating in the outer reaches of NGC 4889, an obsidian monolith catches the light, not a sleek, polished structure, but a jagged, irregular mass bearing the unmistakable glint of refined metal. Scans reveal an object unlike any known asteroid, 97% iron and nickel, twisted into geometric formations too precise for random cosmic weathering. Hexagonal pillars branch from its core like the ribs of a long-dead machine, while its surface is etched with grooves that intersect at near-perfect right angles. This isn't just a hunk of space rock. It's a puzzle that blurs the line between natural wonder and something far more unsettling. The metallic megastructure, as astronomers have cautiously dubbed it, defies easy categorization. Natural metallic asteroids exist, but they're typically lumpy and pitted, shaped by eons of collisions. This object's angular features suggest forces beyond mere chance. Some grooves are uniformly spaced, resembling stress fractures from controlled expansion like cooling metal poured into a mold. Others spiral in fractal patterns reminiscent of crystal growth, yet aligned along axes that imply external influence. The most contentious detail, a series of concave depressions dotting one face, each identical in diameter and depth, as if drilled by tools rather than carved by impact. Debate rages over its origins. One camp argues for an extreme natural process, perhaps a rare metallic protoplanet shattered in a collision, its fragments reheating and recooling in the vacuum to form these uncanny shapes. Laboratories on Earth can replicate similar structures under controlled conditions. Molten metal solidifying in zero gravity sometimes forms geometric facets. But critics point out the object's isolation. It drifts alone, with no debris field or sibling fragments to suggest a violent birth. Then there's the tantalizing and contentious alternative: intelligence. The object's nickel content is suspiciously high for random cosmic metals, matching alloys used in human spacecraft for their resistance to radiation. Could this be a relic of some ancient civilization's engineering, a derelict hull or beacon eroded by time? SETI researchers note that its radio reflectivity is unusually high, as if its surface was once deliberately tuned to bounce signals. Of course, cosmic archaeology is fraught with pitfalls. the universe excels at creating patterns that trick us into seeing design, from the hexagonal storms on Saturn to the near-symmetrical faces of distant nebulae. Perhaps the most compelling clue lies in the megastructure's orbit. Unlike most metallic bodies which cluster near galactic cores where heavier elements form, this object roams the halo, the sparse outer region where stars and asteroids are older and scarcer. Its trajectory suggests it didn't originate in NGC 4889 at all, but was captured from intergalactic space, making its metallic purity even harder to explain. Natural processes rarely concentrate metals so efficiently without surrounding silicates or carbon. Whether forged by chaos or craft, the megastructure forces us to confront the limits of our cosmic intuition. It's a reminder that the universe doesn't care about our categories, that what we call natural and artificial may be distinctions too small for the grand canvas of space. Every scan, every theory only deepens the mystery, and somewhere in the darkness the object continues its silent drift, indifferent to the questions it leaves in its wake. Somewhere in the depths of NGC 4889, the universe's tiniest secrets spill into plain sight. Here, in a region no larger than our solar system, quantum fluctuations, those fleeting, subatomic tremors that usually hide beneath the fabric of reality, stretch to magnitudes we can almost see with the naked eye. It's as though a cosmic magnifying glass has been held over the quantum world, revealing particles flickering in and out of existence not just at microscopic scales, but across vast distances. One moment, a patch of space might shimmer with the birth of virtual particles. The next, it collapses back into eerie calm, like the surface of a pond disturbed by invisible stones. This quantum fluctuation zone shouldn't exist, at least not according to our current understanding of physics. On Earth, quantum effects vanish at scales larger than an atom. Yet here, they balloon to kilometers in scope, their chaotic dance imprinting directly on the surrounding gas clouds. Telescopes capture the aftermath, delicate, filamentary structures where matter appears and vanishes in rhythmic pulses. Some strands of gas twist into knots and untangle seconds later, as if space-time itself is knitting and unknitting its own fabric. The effect resembles static on an old television screen, but written across the cosmos in light years rather than pixels. What could possibly cause such a breakdown in quantum decorum? One leading theory points to NGC 4889's monstrous central black hole. Its gravitational tides might be warping the quantum vacuum, squeezing spacetime so tightly that microscopic fluctuations amplify into observable ripples. Picture the way a tidal wave starts as a gentle ripple in deep water, then grows as it approaches the shore. Similarly, the black hole's pull could be stretching quantum effects until they're impossible to ignore. Another hypothesis suggests dark energy, the mysterious force accelerating the universe's expansion, might be concentrated here, its repulsive power destabilizing the quantum foam at scales we've never witnessed. Then there's the chilling possibility that we're seeing evidence of a higher dimensional brain, a theoretical membrane from string theory brushing against our own universe. In this scenario, collisions between brains could send shockwaves through the quantum field, making hidden dimensions briefly visible in these macroscopic tremors. It's a fringe idea, but the math holds a strange allure. After all, if extra dimensions exist, we're better to glimpse them than in a galaxy already defying every other rule. The real enigma, though, is the zone's persistence. Quantum fluctuations are, by nature, fleeting. Yet this region has remained active for decades of observation, its unstable pockets reappearing in the same locations like clockwork. Some researchers speculate an ancient relic might anchor the chaos, a primordial black hole, a cosmic string, or even a singularity left over from the Big Bang, ticking like a metronome as it warps the quantum field around it. Others argue the zone could be a natural amplifier, a celestial feedback loop where each fluctuation triggers the next. Whatever the explanation, the implications are staggering. If quantum effects can scale this large, our fundamental assumptions about reality's stability might need rewriting. Could other galaxies harbor similar zones, invisible only because we haven't known to look? And what happens if such a region grows, expanding until its quantum storms spill beyond their celestial container? For now, the answers are as uncertain as the particles flickering in NGC 4889's strange depths, a reminder that even the smallest rules of the universe can bend given the right conditions. Rising from the galactic core of NGC 4889 like an inverted waterfall, a shimmering jet of antimatter defies both gravity and expectation. This isn't the messy aftermath of a stellar explosion, it's a focused, sustained eruption. Its particles streaming outward in a slender column that stretches thousands of light years before dissipating into the void. Antimatter, the universe's most volatile substance, typically annihilates on contact with normal matter in a burst of energy. Yet here it flows, seemingly untouched, as if some invisible nozzle directs its path. The fountain's very existence challenges our understanding of cosmic particle physics. Where could such a concentrated stream originate, and how does it survive long enough to be observed? The leading theory traces the fountain's roots to the galaxy's central supermassive black hole. As matter spirals toward the event horizon, unimaginable pressures and magnetic fields might rip particles apart, separating matter from antimatter like cosmic ore refined in a furnace. Under the right conditions, the antimatter could be funneled along magnetic field lines and ejected at near light speed, escaping the black hole's grasp before encountering enough normal matter to annihilate. This process would mirror the relativistic jets seen in other active galaxies, but with a critical twist. Normally, those jets contain mostly electrons and protons. An antimatter jet implies a particle sorting mechanism beyond anything we've modeled, one that preferentially channels positrons and antiprotons into a coherent beam. Then there's the mystery of the fountain's stability. In laboratory settings, containing even microscopic amounts of antimatter requires sophisticated magnetic traps. Yet this natural structure maintains its integrity across interstellar distances. Some researchers point to the jet's eerie helical structure, its particles spiraling like water from a rotating sprinkler, as evidence of an embedded magnetic helix, a self-reinforcing field that herds antimatter along its path. Others speculate the fountain might be threading through a pre-existing tube of rarefied gas, where the density of normal matter is too low to trigger widespread annihilation. The most radical suggestion, the antimatter isn't pure. It could be laced with exotic particles that mediate its interaction with normal space, acting as a kind of cosmic insulation. The implications for energy harvesting are staggering. On Earth, we measure antimatter production in atoms at a time, at costs exceeding millions per milligram. Here, an entire river of it flows freely. Capturing even a fraction could revolutionize power generation, propulsion, and medicine. Imagine spacecraft fueled by grams of antimatter, their engines capable of reaching nearby stars in years instead of millennia. Or hospitals wielding antimatter's precision annihilation to obliterate tumors cell by cell. The challenges, of course, are monumental. Harvesting the fountain would require technology capable of surviving its radiation, not to mention the logistical nightmare of transporting it across galactic distances. But the mere fact that such a reservoir exists shifts antimatter from laboratory curiosity to tangible cosmic resource. Yet the fountain's greatest gift might be philosophical. Its presence forces us to rethink matter's dominance in the universe. We've long assumed antimatter was a rare byproduct of high-energy events, a fleeting imbalance quickly corrected. This structure suggests otherwise, that somewhere antimatter might pool, flow, even form structures of its own. Could there be antimatter stars, planets? Civilizations, the questions border on science fiction, but in a galaxy where the impossible seems routine, they demand consideration. For now, the fountain remains both a beacon and a riddle, its particles whispering secrets we're only beginning to decipher. In the heart of NGC 4889, two dead stars perform a gravitational tango so precise it borders on the impossible. These pulsars, spinning neutron stars that beam radiation like cosmic lighthouses, should follow the strict choreography laid out by Einstein's general relativity. Yet their orbit whispers of rebellion. Every rotation, every pulse carries a discrepancy, a tiny but undeniable drift from the predicted path. It's as though an invisible hand nudges them off course, hinting at forces or phenomena beyond our current grasp. The puzzle lies in their timing. Pulsars are nature's most accurate clocks, their beams sweeping past Earth with metronomic regularity. When two orbit each other, as these do, their signals should shift in predictable ways, slowing slightly as they spiral inward, victims of gravitational waves carrying energy away from the system. But these pulsars defy expectations. Their orbital decay rate is off by nearly 8%, a margin too large to blame on measurement error. Either something unseen tugs at them, or our understanding of spacetime's curvature needs revision. One explanation points to dark matter. A diffuse halo of invisible particles could cluster around the binary system, adding just enough mass to alter the pulsar's motion without betraying its presence. Simulations show that if dark matter interacts weakly with itself, a possibility some theories allow, it could form loose gravitational nets around compact objects like neutron stars. The effect would be subtle, but over years of observation, those tiny tugs add up to measurable anomalies. Then there's the more radical possibility: modified gravity. What if Einstein's equations break down under such extreme conditions? Alternative theories, like modified Newtonian dynamics, propose that gravity behaves differently at very low accelerations, precisely the regime where these pulsars dance. While Mond struggles to explain all cosmic phenomena, this binary system might be its strongest case yet. The pulsar separation places them in a gravitational sweet spot, where traditional and modified predictions diverge just enough to match the odd orbital drift. But the most tantalizing clue comes from the pulsars themselves. One spins slightly faster than the other, and their beams intersect at a peculiar angle. Detailed analysis reveals that when their pulses cross, a faint echo lingers, an extra burst of radio waves delayed by microseconds. This shouldn't happen in empty space. Some researchers suggest the echo could be evidence of a quantum vacuum froth, the fabric of spacetime itself churning at microscopic scales, creating just enough resistance to affect the beams. Others propose the pulsars might be wrapped in magnetospheres so intense they briefly trap and re-radiate each other's emissions. Whatever the truth, these stellar corpses hold a mirror to the gaps in our knowledge. They challenge not just how we model gravity, but how we define the fundamental forces shaping the cosmos. With every pulse, they ask, are we missing a piece of the puzzle, or is the puzzle far bigger than we ever imagined? In NGC 4889, even the dead stars refuse to stay silent. Looming in the darkness between stars, a cluster of shadows moves with unnatural precision, blocking the light of distant suns without emitting even a whisper of heat. Telescopes catch the telltale dips in starlight, the signature of something solid passing in front, but thermal scans reveal nothing, no infrared glow. No residual warmth, just cold, starless voids where the laws of physics insist there should be radiation. The objects, roughly 100 of them, drift in loose formation across NGC 4889's outer disk, each one perfectly opaque and perfectly frigid. To astronomers, they present a paradox. How can anything substantial enough to eclipse stars remain utterly invisible to heat sensors? The answer might rewrite our search for extraterrestrial intelligence or reveal a natural phenomenon stranger than fiction. The leading natural explanation points to rogue planets shrouded in exotic ice. Imagine worlds sheathed in layers of nitrogen or methane ice several miles thick, their surfaces chilled to near absolute zero by eons adrift in interstellar space. Such frost giants could theoretically block starlight while reflecting too little heat to detect. The problem: even the coldest known objects emit some infrared radiation, and the scale of these shadows suggests structures far larger than any plausible rogue planet, some spanning widths comparable to our solar system. That discrepancy fuels a more electrifying theory, a Dyson swarm. First proposed by physicist Freeman Dyson in the 1960s, these hypothetical megastructures would be vast arrays of energy collecting satellites or habitats orbiting a star, capturing its light to power an advanced civilization. A mature swarm might consist of millions of individual constructs, arranged to intercept nearly all stellar radiation. While we'd expect such a structure to eventually radiate waste heat, an ultra-efficient swarm could theoretically channel that energy into propulsion or computation, leaving only a cold silhouette against the galaxy. The objects in NGC 4889 match this profile eerily well. Their arrangement suggests deliberate patterning, with gaps between shadows corresponding to plausible transit lanes for civilization-scale traffic. Yet the most compelling evidence lies in what's missing. Stars dimmed by ordinary dust or gas clouds show characteristic spectral changes, specific wavelengths absorbed more than others. These shadows betray no such fingerprints. Whatever blocks the light does so uniformly across all frequencies, as if engineered to be spectrally neutral. Natural materials rarely behave this way. Even stranger, the shadows occasionally flicker in sync, as though responding to some unseen signal or shared power grid. Skeptics counter that cosmic phenomena often mimic artificiality. The pulsar CP1919, discovered in 1967, initially appeared so regular that astronomers jokingly labeled it LGM-1, Little Green Men. Could these shadows be another cosmic prank? One alternative proposes cold molecular clouds magnetically confined into dense sheets, though no known process explains their perfect opacity or coordinated motion. Another suggests primordial black holes flitting through the galaxy, but their gravity would distort background stars in ways we don't observe. For now, the shadows drift on, their true nature locked in darkness. Whether the relics of a fallen empire or a cosmic process we've yet to name, they challenge us to reconsider the boundaries of the possible. In a universe where even emptiness can glow and black holes vanish without trace, perhaps the only certainty is this: NGC 4889's greatest mysteries aren't just hidden in light, they're hiding from it. Stretching across vast swaths of NGC 4889, colossal undulations ripple through the galaxy's gas clouds, wrinkles in the fabric of space itself, frozen in time like the aftermath of a titanic slap. These aren't the gentle waves of a stellar breeze, but jagged crests and troughs spanning thousands of light years, their sharp edges betraying violence on a scale beyond comprehension. Like the wake of a ship long vanished, they hint at some ancient catastrophe, a momentary roar that still echoes through the cosmos billions of years later. The question gnawing at astronomers: what kind of event leaves scars this large, and why haven't they faded away? One compelling answer lies in the galaxy's monstrous heart. Supermassive black holes don't always dine alone when two galaxies collide. Their central black holes eventually spiral together in a gravitational death spiral. The final moments of such a merger send shockwaves through spacetime, powerful enough to slosh entire oceans of galactic gas into these bizarre standing waves. Simulations show the process vividly. As the black holes plunge toward each other, their immense gravity kicks surrounding matter like a stone hurled into a pond, creating ripples that propagate outward at a fraction of light speed. But here's the twist: NGC 4889's ripples don't quite match the models. Their spacing is unusually regular, their peaks too symmetrical, as if the energy that formed them was focused rather than chaotic. This anomaly fuels an alternate theory: an impact from outside the galaxy. Picture another galaxy, perhaps a long-vanished dwarf neighbor, plowing through NGC 4889's disk at a steep angle. The gravitational disturbance would send tsunamis of gas rolling outward, much like a bullet passing through water. Supporting this idea are the ripple's peculiar chemical fingerprints, traces of elements like lithium and boron, which form more readily in low-density environments, as though the intruder was a gas-poor structure that stirred rather than enriched its target. Yet skeptics point out the lack of a visible culprit. No nearby galaxy shows the expected trajectory, and the ripple's sheer scale would require an impactor far larger than any known satellite galaxy. Then there's the timing problem. Galactic collisions leave messy debris-filled streamers of stars, distorted spiral arms, yet NGC 4889's overall structure remains eerily pristine apart from these ripples. If a merger or impact caused them, why is the rest of the galaxy so undisturbed? One radical explanation suggests we're seeing evidence of a dark matter subhalo's passage, an invisible clump of the universe's most elusive substance, whose gravity could theoretically sculpt gas without leaving stellar scars. Another proposes the ripples are fossils from the galaxy's birth, when primordial density fluctuations in the early universe froze into its gas-like wrinkles in a crumpled sheet. The most tantalizing clue, however, comes from the ripple's motion. Most shockwaves dissipate as they travel, their energy bleeding into heating the surrounding medium. These waves appear to be moving inward, their energy somehow replenished as they go. It's as though something at the galaxy's core is still ringing like a bell, its vibrations tuned to frequencies that sustain these structures across eons. Whether that's the lingering heartbeat of a black hole merger, the ghostly touch of a dark matter avalanche, or something even stranger, the ripples stand as a testament to NGC 4889's enduring capacity to defy explanation. They remind us that even the mightiest cosmic events leave whispers behind, and sometimes those whispers roar. Among the glittering sea of stars in NGC 4889, one particular point of light behaves like no other, flashing into existence for days or weeks before vanishing completely, sometimes for decades. Astronomers have catalogued it as the phantom star, a celestial will-o'-the-wisp that defies every rule of stellar behavior. Unlike variable stars that dim and brighten predictably, this one doesn't just flicker. It disappears entirely, leaving telescopes staring at empty space where a sun once burned. The strangest part, when it reappears, its spectrum matches perfectly to its previous state, as if someone flipped a cosmic switch off and on again without disturbing the star itself. The leading explanation points to gravitational lensing with a twist. Normally, lensing occurs when a massive object bends light from a background star, magnifying it temporarily. But the phantom star's disappearances don't align with any known lensing timetable. The intervals are erratic, and the star's position suggests no visible foreground object massive enough to cause such extreme deflection. One hypothesis proposes an invisible rogue black hole drifting between us and the star, its erratic path occasionally aligning to magnify the light before wandering away. Another suggests a dense knot of dark matter, a gravitational lens without a physical form warping spacetime just enough to flicker the star in and out of view. Then there's the more unsettling possibility: spacetime itself might be glitching. Quantum foam theory suggests the fabric of reality is turbulent at microscopic scales. Could some region along our line of sight to the star amplify these fluctuations, creating temporary knots that bend light away like a cosmic blind spot? It's a fringe idea, but the star's reappearances show no redshift or distortion, as if its light takes a perfectly clean path whenever it's visible. Even stranger, the phantom star's light carries no traces of lensing artifacts. No telltale smearing or duplication seen in other lensed stars. When visible, it's crisp, undistorted, almost too pristine. Some astronomers argue this points to an entirely new phenomenon, a star not magnified by an external force, but one that somehow manipulates its own light path. Could it be encircled by a rotating megastructure, a vast prism-like shell that periodically redirects its emissions toward or away from Earth? Or does the star inhabit a region of space-time so warped that light escapes only through brief natural tunnels? The implications ripple far beyond one flickering point of light. If an unseen object causes these vanishings, its mass and motion could rewrite our maps of dark matter distribution. If space-time itself is the culprit, we might be glimpsing physics beyond Einstein's equations. And if the star is somehow engineering its own disappearances? Well, that opens doors best left to science fiction for now. The phantom star remains a cosmic riddle wrapped in darkness, its next appearance as unpredictable as the truth behind its mystery. Nestled within the spiraling arms of NGC 4889, a cosmic chameleon defies every law of celestial optics. A nebula that doesn't just glow, but morphs, its hues shifting unpredictably like a malfunctioning neon sign in the void. Most nebulae wear their colors with pride: crimson hydrogen, turquoise oxygen, the gold of ionized sulfur, their palettes dictated by elemental composition and the energy of nearby stars. But the Chromatic Nebula obeys no such rules. One month it pulses deep violet, the next it flares emerald, then fractures into prismatic bands with no discernible trigger. Spectrographs trained on this ever-changing cloud record wavelengths that shouldn't exist in tandem, as though the gas itself is rewriting quantum physics on the fly. The mystery begins with the light itself. Nebula emissions typically follow strict atomic rules, electrons dropping between energy levels, releasing photons at precise frequencies. Here, the patterns are chaotic. Some shifts occur over weeks, others in minutes, with no correlation to nearby stellar activity or cosmic rays. During one observed episode, a section of the nebula transitioned from infrared to ultraviolet in under an hour, a jump requiring energy levels that would tear ordinary gas clouds apart. Yet the structure remains intact, its filaments twisting unharmed through these impossible transitions. Material composition deepens the puzzle. Spectral analyses reveal no exotic elements, just hydrogen, helium, and trace metals found in any stellar nursery. But the way these atoms behave is anything but normal. Under certain conditions, the helium emits like hydrogen, and the hydrogen absorbs like metals, as if their fundamental properties are being temporarily rewritten. One theory suggests extreme magnetic fields, orders of magnitude stronger than those found near pulsars, could be distorting electron orbitals in ways that alter emission signatures. Another posits quantum entanglement on a macroscopic scale, with particles across light years linked in a way that synchronizes their behavior beyond known physics. Then there's the eerie synchronization. Despite spanning 3 light years, the nebula often shifts color uniformly, as if receiving a galaxy-wide command. No known process propagates changes that quickly. Even light would take years to cross the structure. Unless, that is, the nebula is somehow processing these shifts, with each section knowing when to transition in advance. Some researchers cautiously propose this could hint at self-organizing behavior, a form of emergent complexity we've only seen in biological systems. Others whisper about engineered constructs, hypothetical, smart nebulae, where nanoscale machines manipulate gas properties for purposes we can't fathom. The most haunting clue lies in the nebula's past. Archival images show it wasn't always this volatile. A century ago, it glowed steady crimson like any hydrogen cloud. The transformations began gradually, first subtle tinges of blue, then full spectrum oscillations, as though something within it was waking up. Whether that's a natural phase transition or something more deliberate remains the galaxy's best-kept secret. For now, the Chromatic Nebula continues its silent light show, a reminder that even the universe's most basic building blocks can still surprise us. One day, its flickering hues might reveal whether we're witnessing cosmic evolution or cosmic engineering. Streaking through the outer fringes of NGC 4889 like a bullet fired from some cosmic gun, a lone star races at speeds that defy logic over 1,000 kilometers per second, fast enough to cross the distance from Earth to the Moon in under 7 minutes. This hypervelocity runaway doesn't just outpace its stellar neighbors, it's on a trajectory that will eventually fling it clear of the galaxy entirely, condemned to wander the intergalactic void forever. The mystery isn't just its speed, but the invisible hand that must have launched it. Stars don't accelerate to such extremes on their own. Something or someone had to kick it like a pebble from a slingshot. The most plausible culprit, a supermassive black hole's gravitational wrath. When binary star systems venture too close to these monsters, one star may be captured while the other gets violently ejected, a process astronomers call the Hill's mechanism. The math checks out. The energy required to propel a star to these velocities aligns neatly with the gravitational extremes near black holes. But here's the rub. NGC 4889's runaway shows no trace of its hypothetical partner. No disrupted orbit, no lingering stellar companion, just solitary motion as if it was hurled by a force we can't yet see. Some theorize the original binary might have been torn apart by a second black hole during a galactic merger, a cosmic double kick that left no debris behind. Then there's the collision hypothesis. Picture two galaxies grazing each other in the distant past, their gravitational tides plucking stars like fruit from a tree and flinging them into the abyss. Computer simulations show such encounters can produce hypervelocity stars, but rarely with this level of precision. The runaway's path is too straight, too unwavering, as if aimed deliberately rather than scattered by chaos. Its trajectory points back to a region of the galaxy now eerily quiet, devoid of the dense star clusters or black hole activity typically linked to such extreme ejections. What makes this star truly exceptional is its composition. A blisteringly hot blue straggler, a type of star that shouldn't exist in isolation. These stellar oddities usually form in crowded environments where collisions or mergers rejuvenate aging stars, granting them unnatural youth and heat. Yet here one blazes alone, its surface temperature defying the cold emptiness around it. One explanation suggests it was already a blue straggler when ejected, wrenched from a densely packed cluster during the cataclysm that sent it flying. Another, more radical idea posits that its speed itself altered its evolution. The friction of interstellar gas or some unknown relativistic effect heating its outer layers as it tore through space. The most tantalizing clue lies in the star's wake. Trailing behind it is a faint, ionized trail, not the usual bow shock seen around fast-moving stars, but a series of pulsating knots resembling breadcrumbs left in spacetime. Some researchers interpret these as echoes of periodic energy releases, as if the star's core is undergoing repeated upheavals triggered by its flight. Others speculate the knots could mark where dark matter filaments, stirred by the star's passage, briefly interacted with normal matter. If true, this cosmic fugitive might be doing more than escaping the galaxy. It could be mapping the invisible scaffolding of the universe itself. Whether propelled by black holes, galactic violence, or forces we've yet to name, this star is more than a curiosity. It's a test subject for extreme physics. Its very existence challenges our models of stellar dynamics, offering a front-row seat to phenomena usually confined to supercomputer simulations. And as it crosses the boundary into intergalactic space, it carries with it a silent question. In a universe where stars can be hurled like shrapnel, what other unthinkable energies might lurk in the darkness? Amidst the swirling chaos of NGC 4889, a small pocket of order emerges, an intricate, self-repeating tapestry of stars and gas that mirrors itself on ever smaller scales. This fractal galaxy fragment, no larger than 1/100th of the Milky Way, unfolds like a cosmic snowflake, its branching arms splitting again and again into near-identical substructures. At first glance, it resembles computer-generated fractals, those infinitely complex mathematical shapes that repeat whether you zoom in or out. But this isn't an abstract simulation. It's a real, physical region where the universe seems to have stamped the same pattern across light years, as if nature itself got stuck in a loop. The discovery sent shockwaves through astrophysics because galaxies aren't supposed to behave this way. Large-scale structures like spiral arms form through gravity and rotation, their shapes smoothed by billions of years of collisions and turbulence. Yet here, the gas clouds curl into delicate fern-like fronds, while star clusters arrange themselves in spirals within spirals, down to scales of just a few light days. It's as though someone took a Mandelbrot set and painted it across the cosmos with stars. Even more baffling, the fragment's boundaries are razor-sharp, a sudden transition from chaotic interstellar soup to geometric perfection, like finding a polished diamond cube tumbling in a stormy sea. One theory points to an ancient galactic collision so precise, so finely balanced that it sent shockwaves reverberating through the gas in just the right way to create standing waves of structure. Picture two galaxies brushing past each other at the perfect angle, their gravitational wakes interacting like ripples in a pond, freezing mid-collision into this eerie symmetry. The math nearly works. Fluid dynamic simulations can produce temporary fractal-like patterns under such conditions, but never with this level of detail or longevity. The fragment appears billions of years old, far outlasting any known transient structure. Then there's the dark matter hypothesis. Could invisible, fine-grained dark matter be sculpting the gas into these recursive shapes? Some models suggest certain dark matter particles might interact weakly with themselves, creating intricate density patterns that subtly steer normal matter into alignment. The fragment's location adds weight to this idea. It floats near a region where gravitational lensing hints at an unusually complex dark matter distribution. Yet even this explanation strains credibility. Self-interacting dark matter might explain faint large-scale filaments, but the fragment's microscopic precision defies known physics. Perhaps most mind-bending is the fragment's apparent computational efficiency. Natural processes tend toward entropy, yet here we see a pocket of the universe seemingly optimizing for pattern replication, a hallmark of algorithmic compression. Some researchers cautiously suggest the structure might be evidence of a self-organizing principle deeper than gravity, a previously unknown law that favors information density over energy dispersal. Others inevitably whisper about artifacts. Might this be the universe's version of a corrupted file, or worse, a signature? For now, the fractal fragment drifts on, its spirals spinning smaller and smaller toward some unfathomable limit. Whether it's a freak accident of physics, a window into dark matter's hidden talents, or something beyond our current lexicon, one thing is clear. In NGC 4889, even chaos has a blueprint. Hidden in the turbulent heart of NGC 4889, the remnants of a long-dead star perform a ghostly encore, flaring back to life in precise, cyclical bursts as though time itself has folded to replay its final moments. This isn't an ordinary supernova remnant. While most fade steadily into the darkness, this one pulses with eerie regularity, its light echoing across the galaxy every 12 years like a cosmic heartbeat. Each flare mirrors the original explosion's spectral signature down to the atomic level, as if the star's death throes are trapped in an endless loop. The phenomenon defies every law governing how supernova decay and how light travels through space. Light echoes themselves aren't uncommon. When a star explodes, its flash can illuminate surrounding dust clouds years or centuries later, creating delayed reflections. But those echoes are supposed to be one-time events, fading as the light scatters. This remnant breaks the rules. Its repeating pattern suggests something far stranger. A structure that somehow captures and re-emits the original explosion's energy on a schedule. One theory proposes an intricate shell of ultra-reflective dust, shaped like a nested set of spheres around the dead star. As the initial supernova light ricochets between these layers, it could emerge periodically like a lighthouse beam piercing fog. The math almost works, except for one flaw: no known material reflects light with perfect efficiency across 12-year intervals without dimming. Then there's the gravitational lensing hypothesis. Perhaps the remnant sits in front of a dense region of dark matter, warping spacetime into a natural hall of mirrors that bends light back toward us in cycles. Simulations show that under bizarrely specific conditions, light could orbit a massive object before escaping, creating delayed repetitions. But the timing is too precise, the spectral fingerprints too identical. Gravitational lenses typically distort light, stretching or smearing its colors. This echo arrives untouched, as pristine as the day the star died. The most tantalizing clue lies in the echo's energy. Supernova unleash enough power to outshine galaxies, yet these repeating flares carry exactly the same intensity as the first recorded burst. Conservation of energy demands that reflections lose strength over time, yet here the brightness remains stubbornly constant. Some researchers speculate the remnant might be tapping into an external energy source, a nearby pulsar's magnetic field, or even vacuum energy to recharge its echoes. Others propose the unthinkable, that we're witnessing not a reflection but a genuine recurrence, some unknown physics resurrecting the explosion moment by moment. The implications ripple far beyond one stellar corpse. If matter or energy can be trapped in such perfect cycles, it might hint at mechanisms for storing information across cosmic timescales, or even ways the universe records its own history. For now, the echoing supernova remains a riddle wrapped in light, its next flare already ticking toward revelation. In a galaxy where even death doesn't stay dead, the rules of reality seem written in pencil, not ink. Deep within the tangled magnetic fields of NGC 4889, a fundamental law of physics appears to crack, a region where magnetism might not come in pairs as we've always known it, but in solitary, unpaired poles. These hypothetical particles, called magnetic monopoles, have eluded scientists for over a century. According to every textbook, magnets have two ends, a north and a south. Cut one in half, and you don't get isolated poles, just two smaller dipoles. Yet here, in this peculiar pocket of the galaxy, the magnetic fields twist in ways that suggest something extraordinary, singular norths or souths wandering free like cosmic orphans. The evidence lies in the field's behavior. Normally, magnetic field lines form continuous loops flowing seamlessly from one pole to another. But scans of this region reveal abrupt terminations, lines that simply start or stop mid-void, as if anchored to invisible particles that don't play by the usual rules. These frayed edges align eerily with predictions from quantum theory, which allows for monopoles under extreme conditions like those just after the Big Bang. Could NGC 4889 be harboring relics from the universe's birth, fragments of a time when symmetry ruled and the laws we know hadn't yet snapped into place? One compelling clue comes from the galaxy's core. The supermassive black hole at its center spins at a staggering fraction of light speed, dragging spacetime around it like a whirlpool. Such extreme rotation could have twisted primordial magnetic fields into knots dense enough to pinch off into standalone poles. Think of it like twisting a rubber band until it snaps, except here, the rubber band is the fabric of spacetime itself, and the snap creates fractures where magnetism sheds its paired nature. Supporting this idea, the anomalous fields cluster along the black hole's rotational axis, precisely where models suggest monopoles might accumulate. Then there's the temperature signature. The region emits faint, low-frequency radio waves with a spectral fingerprint that matches what theorists expect from monopole interactions. When these particles move through plasma, they should create subtle disturbances, tiny ripples in the galactic medium. The readings here show just that, patterns of interference with no ordinary explanation. Some researchers argue it could be background noise from pulsars or turbulent gas, but the signal's consistency across decades of observation makes that unlikely. The implications are staggering. If monopoles exist, they could rewrite physics from the ground up. Quantum mechanics and electromagnetism would need retooling to account for particles that carry magnetic charge, the way electrons carry electric charge. Practical applications loom. 2 monopoles could revolutionize energy storage, enabling ultra-efficient magnetic batteries or even new forms of propulsion. But the grandest prize might be cosmological. Monopoles are a key prediction of grand unified theories, frameworks that attempt to merge all fundamental forces. Finding them would be like uncovering a Rosetta Stone for the universe's deepest laws. Yet skeptics urge caution. The universe loves to mimic the impossible. What looks like a monopole signature could be an exotic plasma effect or a quirk of gravitational lensing warping our observations, until someone captures one directly, perhaps in a future deep space particle trap. The mystery remains open. For now, NGC 4889's twisted fields stand as both a beacon and a riddle, teasing us with the possibility that somewhere in its depths, magnetism's oldest rule is being broken. Floating in the depths of NGC 4889, a spectral circle of gamma rays glows with otherworldly intensity, a perfect, luminous ring suspended in the void with no visible source to power it. This isn't the aftermath of a supernova or the fiery debris of colliding stars. It's a structure that shouldn't exist, a loop of the universe's most energetic radiation, spanning nearly 20 light-years across with absolutely nothing at its center. No pulsar, no black hole, not even a wisp of dust to explain the phenomenon. The ghostly gamma-ray ring pulses with the fury of a billion suns, yet its origin remains one of the galaxy's most confounding riddles. Gamma rays don't just appear out of nowhere. They're born in the universe's most violent events: supernova, neutron star collisions, the voracious appetites of active black holes. Yet here, the radiation forms a near-perfect geometric shape, its edges crisp and symmetrical, as if drawn by some cosmic compass. What could possibly sculpt such a precise structure without leaving a trace? One leading theory points to dark matter, the invisible scaffold of the cosmos. If certain dark matter particles collide and annihilate, they could theoretically release bursts of gamma radiation. Under specific conditions, these interactions might occur along a circular boundary, like ripples radiating outward where 2 unseen currents meet. The ring's uniformity supports this idea. Its flawless shape suggests a symmetric process, something governed by hidden physics rather than chaotic stellar violence. But there's a twist. Dark matter annihilation should produce a faint, diffuse glow across the galaxy, not a razor-thin ring. This structure's sharp edges hint at something more deliberate, almost engineered. That's where the black hole hypothesis comes in. Some astronomers propose the ring could be the shadow of a jet from a supermassive black hole, one that's currently inactive or angled so precisely away from us that its central engine remains invisible. Imagine a black hole's relativistic jet, a beam of charged particles screaming into space at near light speed, striking a distant cloud of gas and igniting a circular shockwave of gamma rays. If the jet has since turned off or shifted direction, we might be seeing only its echo, a ghostly aftermath frozen in time, yet even this explanation falters under scrutiny. The ring's gamma-ray signature doesn't match typical jet interactions, lacking the telltale energy variations or polarization patterns seen in other galaxies. Worse still, there's no sign of the cloud or filament that such a jet would have needed to collide with to create the ring. It's as though the radiation simply decided to arrange itself this way, defying cause and effect. Then there's the timing. Gamma rays are ephemeral, scattering or absorbing quickly in interstellar space. For the ring to remain so distinct, it must either be continuously replenished, implying an ongoing, hidden process, or somehow frozen, in place by a mechanism we don't yet understand. Some researchers speculate the ring could be a topological defect in spacetime itself, a leftover kink from the early universe's rapid expansion. These cosmic wrinkles, predicted by string theory, might concentrate energy along their edges, creating visible structures where the fabric of reality is subtly torn. The most haunting possibility: we're seeing the imprint of something beyond our dimensional perception. Just as a three-dimensional object passing through a two-dimensional plane would appear as a growing, then shrinking circle, the gamma-ray ring might be the shadow of a higher dimensional event, a collision or collapse occurring in realms we can't directly observe. It's a radical idea, but in a galaxy where black holes vanish and stars flicker like broken streetlights, radical might be the only lens left. For now, the ring pulses on, a silent enigma etched in gamma rays. Whether it's the tombstone of a dark matter battle, the aftermath of a black hole's forgotten outburst, or a crack in reality's foundation, one thing is certain: in NGC 4889, even the emptiness knows how to haunt. At the heart of NGC 4889's labyrinth of mysteries, light itself bends to an unseen sculptor's will, forming a celestial mirage so precise it seems etched by divine hands. The warped Einstein cross isn't just a gravitational lensing effect. It's a cosmic funhouse mirror reflecting one distant quasar into four distorted images, arranged in a lopsided cross that flickers against the void. Normally, such crosses appear symmetrical, their perfect geometry betraying the smooth mass distribution of the foreground galaxy warping the light. But here the cross twists, its arms uneven in brightness and spacing, as if the lens itself is groaning under invisible weight. The distortion whispers a tantalizing secret: something massive, something clumpy, lurks where our telescopes see only empty space. Gravitational lenses are supposed to be predictable. When a massive object like a galaxy or black hole aligns perfectly between Earth and a distant light source, its gravity bends the incoming light, creating rings or multiple images of the background object. Einstein's equations describe this phenomenon with elegant precision. Assuming the lens's mass is evenly distributed, the warped cross shatters that assumption. Its uneven images suggest pockets of concentrated mass within the lensing galaxy, regions so dense they warp space-time more fiercely than their surroundings. Think of it like looking through a lumpy pane of glass where thicker patches bend light more sharply. Only here, the lumps might be rogue black holes, dark matter subhalos, or even primordial defects in space-time itself. The quasar at the cross's heart compounds the mystery. Most lensed quasars flicker randomly, their brightness dancing to the chaotic tune of accretion disks. This one pulses in sync across all four images, despite the light from each taking slightly different paths around the lens. That synchronization implies something extraordinary. The lens isn't just warping space, it's stretching time, delaying some images more than others in ways that shouldn't balance out. One explanation: the lensing galaxy hosts a spinning supermassive black hole, its rotation dragging spacetime like honey on a spoon, tweaking the quasar's apparent rhythm. Another possibility: the lens is actually two galaxies overlapping along our line of sight, their combined gravity creating a lens within a lens, a hall of mirrors where light's journey becomes impossibly complex. Yet the most electrifying clue lies in the gaps between the cross's arms. High-resolution radio maps reveal faint, spiderweb-like filaments connecting the images, streamers of plasma that shouldn't survive the trip around the lens. They're too coherent, too organized, as if magnetic fields we can't see are shepherding them into place. Some astronomers speculate these filaments might trace the boundaries of dark matter filaments, the universe's hidden scaffolding briefly illuminated by the quasar's passage. Others argue they're evidence of echoes from the lensing galaxy's own active core, its long-dead jets fossilized in the interstellar medium, now resonating with the quasar's light. The warped Einstein cross isn't just a curiosity, it's a stress test for cosmology itself. Its distortions challenge our models of how mass clumps in galaxies, how dark matter interacts with light, even how time flows in warped spacetime. Every new observation peels back another layer, revealing a universe far lumpier, far more dynamic than we ever imagined. And somewhere in those twisted beams of starlight, a question lingers. If gravity's rules bend this easily in NGC 4889, what else have we gotten wrong? Deep within the turbulent plasma clouds of NGC 4889, something stirs. An undulating ribbon of ionized gas that twists and reforms with eerie purpose, its movements too deliberate to dismiss as random cosmic currents. Astronomers first catalogued it as just another stellar nebula, until time-lapse observations revealed the impossible, filaments splitting, merging, and even seeming to navigate around obstacles like a school of fish avoiding a reef. This isn't merely charged gas responding to magnetic fields. It's a pattern that mirrors the hallmarks of life itself. The controversial plasma lifeform hypothesis suggests we might be witnessing biology's most radical incarnation, creatures not of carbon and water, but of electrified particles dancing in the void. The idea isn't as far-fetched as it seems. On Earth, we've observed plasma crystals in laboratories, self-organizing structures where charged dust particles align into lattices under electrical stimulation. Under the right conditions, these formations exhibit complexity bordering on lifelike behavior, with some even showing primitive replication. Scale this up to interstellar proportions, where plasma clouds stretch across light years and magnetic fields replace chemical bonds, and the recipe for exotic life becomes plausible. In NGC 4889's chaotic heart, where temperatures swing from near absolute zero to millions of degrees, such structures might have evolved beyond simple crystals into something far more sophisticated. Critics argue that movement alone doesn't equate to life. Gas clouds in space are known to follow magnetic field lines, creating illusions of intentional motion. But the nebula in question does more than drift, it adapts. When a passing star's solar wind disrupted its environment last year, the filaments didn't just scatter. They recoiled, then regrouped along new pathways, as if mapping the disturbance and responding. Even more perplexing, spectrographs detected rhythmic fluctuations in the plasma's energy states, pulsing in sequences that resembled primitive communication patterns observed in bacterial colonies. The debate hinges on definitions. Traditional biology requires metabolism, reproduction, and evolution. Plasma-based life would rewrite those terms. Instead of consuming organic matter, it might feed on electromagnetic energy, metabolizing the galaxy's ambient radiation. Reproduction could involve fractal splitting filaments pinching off into smaller, self-sustaining units. As for evolution, the staggering timescales of cosmic phenomena might allow for selection pressures we can't yet fathom. Imagine a life form that lives for millennia, its generational changes unfolding slower than human civilization's entire history. Then there's the eerie resonance with human myth. Cultures worldwide describe spirits made of fire or lightning. Could plasma life have sparked such legends? The nebula's flickering tendrils bear an uncanny resemblance to descriptions of celestial serpents or jinn, beings woven from energy rather than flesh. Scientists dismiss this as coincidence, but the symbolic parallels linger. Skeptics demand irrefutable proof, a documented instance of information storage perhaps, or a clear evolutionary leap. Until then, the nebula remains a tantalizing what-if. But in a universe where black holes sing and stars vanish without trace, why couldn't life take forms beyond our earthbound imagination? Whether this shimmering enigma is truly alive or merely a masterpiece of cosmic physics, one thing is certain: NGC 4889 has once again blurred the line between the impossible and the inevitable. At the very center of NGC 4889, where most galaxies host a brilliant supermassive black hole, there lies instead an abyss so profound it swallows even the idea of light. This isn't the familiar darkness of an event horizon, it's something far more unsettling. telescopes register the gravitational pull of a core weighing billions of suns, yet no accretion disk glows, no jets of plasma scream into the void. Just silence, a perfect, lightless sphere where the galaxy's spiral arms twist to meet nothing, or rather, nothing we can see. The leading theory points to an unfathomably dense knot of dark matter, not the diffuse halo that cloaks most galaxies, but a concentrated nucleus, a tangled ball of the universe's most mysterious substance. Dark matter isn't supposed to clump this tightly. Its particles are thought to lack the interactions needed to collapse into such compact structures. Yet the motions of nearby stars betray the truth. They whip around this invisible anchor at speeds that would require a black hole's grip, yet their orbits spiral in patterns no black hole should produce. Some drift too close, passing where an event horizon ought to shred them, and emerge unscathed. It's as though the core's gravity wears a mask powerful enough to steer galaxies, yet strangely gentle up close. Alternative explanations veer into speculative frontiers. Could this be a gravastar, a theoretical object where a black hole's singularity is replaced by a bubble of exotic vacuum energy? Or a Planck star, a remnant of a black hole that has somehow exited its collapsed state, leaving behind an ultra-dense relic frozen just shy of singularity? These ideas straddle the line between astrophysics and philosophy, challenging our very definitions of mass and space. Then there's the timing anomaly. Every few decades, stars near the core experience subtle, synchronized speed changes as if the hidden heart briefly flexes its influence. The pattern defies randomness, suggesting something beneath the darkness might be pulsing. Dark matter isn't known to oscillate this way, nor do black holes rhythmically vary their pull without consuming matter. One daring hypothesis proposes the core isn't a single object at all, but a swarm of primordial black holes from the universe's first second, locked in an intricate dance that creates these gravitational ripples. The most haunting possibility, we're seeing the shadow of a higher dimensional object, a cosmic knot where our three-dimensional space intersects with another reality's gravity. String theory allows for such structures where mass from another dimension could imprint onto ours without fully revealing itself. If true, NGC 4889's core might be less an object and more a fingerprint, pressed into the fabric of our universe by something we'll never fully comprehend. For now, the galaxy's hidden heart keeps its secrets, a reminder that some mysteries refuse to fit into tidy boxes. Whether it's dark matter defying its own rules, a new phase of collapsed matter, or a window into dimensions beyond our own, one truth remains: in the cosmos, the darkest voids often hold the brightest revelations. From phantom black holes that vanish without a trace to rogue diamond fragments the size of moons, NGC 4889 isn't just a galaxy. It's a gallery of cosmic anomalies that rewrite the rules of reality. We've wandered through its labyrinth of mysteries, from the self-repairing crystalline shard to the plasma nebula that moves with eerie purpose, each discovery peeling back another layer of the universe's strangeness. The Jellyfish Nebula's rhythmic radio pulses, the fractal star cluster that mirrors itself infinitely, the gamma-ray ring glowing with no source, these aren't just oddities. They're cosmic breadcrumbs leading us toward truths we've yet to imagine. Consider what these objects demand of us. The hypervelocity star racing toward intergalactic exile forces us to rethink the limits of gravity's slingshot. The warped Einstein cross with its uneven arms whispers of dark matter's hidden structures, and that silent, lightless core at the galaxy's heart. It's a gravitational paradox, a reminder that even black holes, the universe's ultimate monsters, might have rivals we don't yet understand. Every anomaly here is a crack in the foundation of astrophysics, inviting us to question, to experiment, to dream bigger. This galaxy doesn't just defy expectations, it obliterates them. Where else could you find a magnetic monopole hinting at the universe's birth, or a supernova that replays its own death like a cosmic hologram? These aren't quirks of observation, they're clues to forces and dimensions beyond our current science. The repeating radio bursts, the backward-moving gas cloud, the fractal fragment, each one is a piece of a puzzle we're only beginning to assemble. So what's your take? Could the diamond shard be the wreckage of an ancient civilization's megastructure? Might the plasma filaments truly be alive? The comment section is your launch pad. Drop your wildest theories, debate the possibilities, and let's keep the conversation as boundless as the galaxy itself. And if you're hungry for more cosmic conundrums, don't just hit subscribe, ring that notification bell, because the universe isn't done surprising us, and neither are we. Until next time, keep looking up. The strangest discoveries are still out there, waiting in the